Hello, everyone, and welcome to this webinar. I'm Francis Seeley from GlobalNet 21 and Enfield Voices, and I'm also from the Enfield Climate Action Forum. And we're doing this webinar in conjunction with an Over 50s forum in Enfield. And we're doing it with them because they're very keen that their children and their grandchildren have a life that they can live where there is well-being. And one of the things that's going to threaten that is climate change. Now, we're going to look at how we can address climate change. We've looked at lots of that issue before in terms of cutting emissions, but what we haven't done is looked at carbon offsetting, which is a major way, an increasingly major way of tackling climate change. And we've got with us today Tim Dixon, who is going to tell us a bit about this. He's going to do a small presentation. He's going to answer some questions. And we're going to look at the advantages of carbon capture and some of the questions about it as well. So Tim, thank you for joining us today. Maybe you could start briefly by telling us just a little bit about your background.
Okay, thank you very much, Francis, and to all of your groups, and thanks for the opportunity to talk today. So yeah, I'm Tim Dixon. I'm the head of IEAGHG, which is an international research organisation into carbon capture and storage. And I've been with them 13 years. Before that, I was with the UK government, working on policy in this area. And before that, working in renewables and other clean energy technologies, very much with an international focus. And I should just add the caveat at the beginning that the work that my organisation does is technical evidence-based providing, and we don't do policy prescription. We're not policy advocates. We just provide the evidence base then for the policymakers themselves to make decisions upon. So I try not to venture into prescribing policy, and if I do, it's my own personal view and not that of my organisation.
Okay, well, we'll ask questions about evidence-based, but we might sort of trespass into the other area just a little. You know, when people talk about offsetting, in most people's minds, they think, planting trees. Now, planting trees is a form of carbon capture, but there is, you know, some criticism about how effective that is, but it's not the only form, is it? Can you tell us a bit about what carbon capture is?
So, and when you say offsetting, yeah, what you're talking about is removing CO2 from the atmosphere, separate to whatever industrial activity may be putting it up there. So what I'm going to talk about is carbon capture and storage that can be used for that, but it can also be used for stopping the emissions in the first place. And carbon offsetting, yeah, it's an economic tool that's been used for many years in the climate change world, where on the basis that the CO2 in the atmosphere, it doesn't matter where it comes from, it shouldn't be there. And if you can stop it getting into the atmosphere or remove it from the atmosphere, it's a good thing to do, and it might be cheaper to do in some locations than in others. And so that started the whole offsetting, international carbon trading. The clean development mechanism under the Kyoto Protocol was based upon that, enabling or facilitating low carbon projects in developing countries so that developed countries could use those carbon credits against their obligations. There's quite a large, broad spectrum of things under offsetting, and the carbon capture storage can be used in a specific way for one way of dealing with that.
Yeah, okay. I know you've got a presentation now, so let's go through that, and then that will be explained in a bit more detail.
Okay, so that's the introduction, and this is the disclaimer to say that we're associated with the International Energy Agency, but we're not them. We're IEAGHG, we're autonomous. So what I say doesn't represent their views. So let's just start with, where do greenhouse gas emissions come from? And this is the IPCC's work from 2014. And the bad news is, look at the energy sector. It's hard to read, but that biggest clout is the energy sector. After that, it's agriculture, forests, and land use, then industry, transport, and buildings. Now, that's the bad news. The good news is the energy sector and industry are characterized by having many large point sources of carbon dioxide. And that lends themselves to having carbon capture plant fitted on them to capture the CO2 to stop it from going into the atmosphere. And actually, carbon capture and storage can be used in the production of hydrogen as well. And hydrogen is very exciting because you can use hydrogen to reach these other hard to do bits, not agriculture and forest and land use, but transport, of course. and heating in buildings as well. Agriculture and land use is hard, and my organisation, we don't try to deal with those emissions. But we're focusing on the energy sector, which includes industry. And so my colleagues in the International Energy Agency produced their analysis. This shows how the energy sector should reduce emissions. This is their scenarios for getting to net zero by 2070 or by 2050. And basically it says, according to their analysis, we need all of the low carbon technologies, all of the renewables, of energy efficiency, avoided demand, and carbon capture and storage. Well, they have CCUS, use them for utilization in there as well. And CCS plays a big role. Why does it play a big role? Well, let's tell you about carbon capture and storage itself to start with. This is just a simple cartoon. But if you look at the left-hand side, we've got sources, large-scale sources of carbon dioxide, such as power stations that maybe run on fossil fuels, coal and gas, or could be on biomass. We have cement plants. People don't realize that cement plant produce around 7% of the world's CO2 emissions. That's double the amount of aviation. Gas processing, iron and steel production, refineries as well. You capture the CO2 using a range of different technologies that are available, and you gather it together in this hub and cluster model. And normally you transmit it through a pipeline, but you can also use ships and trucks to somewhere where there is suitable geology, and you inject it deep beneath the ground. That's the core of it. It stops it going into the atmosphere by injecting it deep beneath the ground. And if the carbon dioxide has come from fossil fuels, you are in effect putting the carbon back where it came from, deep beneath the ground. I just mentioned biomass. That's interesting because the biomass is regarded, if you get energy from biomass, it's regarded as carbon neutral because it's just taken the CO2 from the atmosphere through photosynthesis recently and then releases it in the process of burning it or whatever. But if you then capture that carbon dioxide and put it deep beneath the ground, you've now got a negative emission technology removing CO2 from the atmosphere. And that can be used for offsetting, but you're also getting energy out of the process as well. And what's not on this diagram is direct air capture. So you can use similar capture technologies, but scrub the CO2 from the atmosphere. And then the important part is you're putting it deep beneath the ground so it's not re-emitted to the atmosphere. The whole point is stopping CO2 getting to the atmosphere where it acts as the main greenhouse gas. And so direct air capture is the one I think that people are looking at with fresh eyes in the concept of offsetting, Francis, as you described. So the one thing wrong with this diagram is the scale, because we're talking about not putting the CO2 just beneath the surface of the ground, but very deep, at least 1 kilometre. And this is a schematic of a real project to scale in Canada, and that's capturing the CO2 from a coal power station and putting it 3 kilometres beneath the ground. And what this schematic shows is the geology going out to the right. Those layers are the sealing layers that CO2 can't come back through. And the ones to the left are geology that has potential for storage or is porous and permeable and will fit the CO2 into it. And what we know, again, this is from the IPCC, is that when you inject CO2, carbon dioxide, into the pore space in rocks, there's various trapping mechanisms. You initially need to stop it coming back up because it's buoyant, but the longer it's in there, all these different trapping mechanisms come into play. Nature makes that happen. The longer it's in the ground, the more secure it becomes. And eventually it starts to become mineral. It turns back to rock. So that's a way of knowing that CO2 storage can be permanent, certainly over geological timescales. And certainly nature has shown us how to do this because there's millions of tons of carbon dioxide in the deep geology already that some people even have been mining out for different purposes in the past. So how do we ensure it's safe and secure and stays down there? That's the role of regulations, to make sure that the right sites are chosen, there's no leakage pathways, and so you have a methodology based around choosing the right site with the right geology, undertaking a risk assessment, and then monitoring the CO2 to make sure it stays down there. And we have CCS-specific regulations already from the United Nations Framework Convention on Climate Change, specifically for developing countries, from the London Protocol for storage beneath the seabed. International Standards Organization's got its specific standards on this now, and then countries as well, as you can see, US, EU, UK, Australia, Japan, Canada, all based around this same methodology of only permitting CO2 injection if it can be shown by the operator that it's going to be safe and secure and permanent for a long time scale. So just to wrap up, because this is all very conceptual, but here's just some photos of some real projects. The one on the left is a Norwegian project in the middle of the North Sea, and that's been operating since 1997, where the Norwegians have been injecting about 1 million tons a year of CO2 back deep beneath the seabed. The one in the middle is the coal power station from that schematic, and that shows the capture plant is the right-hand set of buildings there. And that's the injection site below. The injection side, the storage side is actually quite modest in scale in terms of equipment and infrastructure. And the one on the right is a refinery of shells, also in Canada. And again, that's the storage site below. And each one of these is putting about 1 million tons a year deep beneath the ground. So that's a quick 101 on CCS. I'm happy to take questions from you, Francis, and from the listeners as well.
Okay, well, thanks. That gives a really nice brief, summary of what it's all about. But it's not new technology, is it? I mean, some people think it's brand new. It's actually been around for 45 years, and I guess the technology has changed, and the carbon capture has become more efficient. So it's not a new technology. It's been one that is sort of proven its point, isn't it?
That's correct. And the really long-term use of it was around getting extra oil out of the ground because it can be used for that. And in the process, the CO2 gets trapped down there. And that annoyed the oil companies generally because they were paying for the CO2. But it's quite a good thing. That's what you want to happen in any case. And that's the principles of that trapping are the principles that keep it safe down there when you just inject it for straight storage as well. But yes, the project everyone points to is that Norwegian project, which is a straight storage project running since 1997. And then we've got about 20 large-scale projects operating now around the world. That's large scale, about 1 million tons a year scale. And there's plenty more pilot scale demonstrations and so on. And it's important that each country does it for themselves because their geology is different. It varies site to site. You're working with the natural systems and the geology. And you've got to fit it within each country's own regulations and regulatory regimes. Yeah, there's a good history of being able to do it, but it's not been done at the scale needed. And that's certainly very, very true.
Well, I'm going to ask you about the scale needed in a minute, but the capacity is there, isn't it? I gather the United Nations International Panel on Climate Change has said there's a potential capacity for carbon capture of 2 trillion tons. So in a way, it's unlimited potential, isn't it?
Yes, there is. There's far more geological storage capacity than we could possibly use with all the emissions we might want to do. It's not evenly distributed. That's an issue, but then we've got transport means, including shipping, and that's where the Norwegian project is very interesting. The Northern Lights project, where they're developing a new offshore storage site off the west coast of Norway, and prepared to take and planning to take carbon dioxide from industrial sources around all of Western and Northern Europe. So these industrial sites don't have to worry about developing their own storage site. They can ship it off to the Norwegians from Ireland, from France, from Belgium, from Germany, from Denmark, from Sweden. But in total, you're right, absolutely right. There's plenty of geological storage around the world.
So if people looked at what you were saying, they would say, hallelujah, we've saved the planet. But there are some reservations about it that maybe we're talking about. And one that people worry about is clearly safety. And they fear that a new fracking technology is coming up where you're actually inserting materials or minerals into the Earth's surface that could leak and cause pollution in future years. How do you respond to that?
Yeah, well, a really important question, and absolutely the right questions to ask, and that's the purpose of the regulations, to ensure that the CO2 storage side is done safely and securely. And you mentioned fracking. And fracking is like the opposite to this, in a sense that fracking's intention is to go down and fracture the geology. With CO2 injection, you want the geology to remain intact. So you put the CO2 in gently, you know your injection pressures, you know the fracture pressures of the rock formations, and you don't exceed those. For example, the regulations may say only up to 90% of the pressure of the fracture pressure. So yes, the whole point is keeping the CO2 down there, and that's the purpose of the regulations. And everything that's been done to date gives tremendous confidence in being able to do that. And actually, to give credit to the oil and gas industry, they do have this knowledge and historical expertise in getting fluids and gases out of the ground and injecting some back in again. And it's the same sort of expertise and knowledge that you're using for putting CO2 back deep beneath the ground as well. But it's absolutely the right question to ask, because it's a thing you don't, it's not the purpose of doing CO2 storage.
Yeah. I mean, I know the IPCC has said it's safe, and there's been some research in Alaska which has confirmed that. So it may be safe in the medium, even the long term. But you raised an interesting point yourself. Are we doing it fast enough? I mean, the IPCC has said we have to keep temperatures below 1.5 degrees by the end of the century. Many scientists are saying that will happen in the next 5 or 10 years. And the trajectory now for the end of the century is about 4%. And, we found out in the last few days that there is more atmospheric CO2 around than there has been in the atmosphere for 4 million years. So, can you do it fast enough? It's a huge, huge problem.
Yeah, well, we absolutely need to scale up. And we need to do that across all the low carbon technologies as well. The IEA, my colleagues in Paris, keep track of all the technologies, and they're all really behind where they should be. But carbon capture and storage is sort of like the new kid on the block in the technologies, and it's coming from a low base to start with, a very low base to start with. So we've just got these 20 large-scale projects. We've got enough knowledge to know that the technologies work, but we need something like, I can't remember the exact number, maybe 2,000 projects by 2030. We need 1.6 gigatons being stored by 2030. We need 7,000 gigatons being stored by 2050. So we've got to go up by, an order of magnitude on the projects we've got. We know that industry can build that quickly. We've looked at, as an analogy, the oil and gas industry. When stuff's been exciting for them, like high oil prices, they build new developments and build pipelines and things very quickly when they want to. They can do it again for CO2 capture and storage if the policies are in place. And that's the thing that's really missing, is the policies. The technologies there are ready to use. The policies are not there to make people do it, to make companies do it.
That's interesting, that, because I read a study for the European Commission into United Nations sanction projects, and they found that 3/4 of the projects were unlikely to have resulted in additional emission reductions, meaning they would have happened anyhow, and only 2% were likely to be classed as an additional. So when you're trying to get your
projects.
Is it offset?
I think that's offset projects, which are not the same as CCS projects. The CCS can be a subset of those offset projects, but I think those are projects outside of the EU where they were looking to get carbon credits in for use in the EU. And yes, with those sorts of things, that exactly the point. They've got to be proven to be additional to what would have happened otherwise. And so the Kyoto Protocol has its rules in place, its transparency, its verification, its validation procedures, and transparency. And generally, it works very well. But there's also this market for what they call grey credits, grey carbon credits, and you can get those from offsets. And yes, I don't know the report you're referring to, but I suspect they're referring to that grey market where the projects might have been going to happen anyway. And so, yes, there's a question over, and it comes down to the accounting and being, proving that the carbon accounting is open, honest, transparent, doesn't duplicate, doesn't double count carbon credits where projects exist, and reduce emissions compared to what would have happened otherwise.
I mean, I think that
what would have happened otherwise as well.
I mean, I think that report also refers to the fact that, that aviation, shipping and industrial processing like chemical stills and cement are very, very difficult to capture. There are industries which are easier and industries that are hard, but the ones that are hard are actually the ones that are major emitters. So that's another problem, isn't it?
It is indeed. And CCS comes into, cement we can do on CCS on cement, and the Norwegians are just building the first full-scale project at the moment. The Canadians are not far behind. The Europeans are not far behind them as well. But it really needs to happen quickly. And I think the cement industry's woken up to this and are putting a lot of effort in their global association efforts. The other big sources that you mentioned, aviation, is very hard, and shipping, partly because the accounting issue about who's responsible for the emissions when a plane or a ship is flying in international airspace or international waters. That's the bunker fuels issue. Nonetheless, whether it's difficult to account and which country is meant to be accountable, it's still an emission that needs to be dealt with. And so that's where potential for synthetic fuels produced from carbon dioxide are there for aviation, and the very strong potential for hydrogen to be used as a fuel in shipping. And the Norwegians are looking very seriously into this. Your large-scale ships can run on hydrogen, which produces water vapor as the main emission out of it. And CCS can play a role there, or you can get your hydrogen from renewable electricity doing electrolysis as well. That's if you, in the scenario in the future where you might have surplus renewable electricity, which would be really good, you can get renewable green hydrogen, as it's called. If you make hydrogen from methane, natural gas, and with CCS on, that's called blue hydrogen. They've given these labels to hydrogen already before we've even started using it widely.
Okay, well, let's go stray a bit into the policy area, so forgive me if I do it. $64,000 question, really. I mean, academics at Lancaster University studied this issue, and they concluded that future offsetting, future carbon capture is a problem because it will stop industries stopping their emissions. They will say, right, we can carbon capture, so we can carry on as business as usual. We can keep polluting the atmosphere because someone out there has got the technology to capture our pollutions. They want business as usual. How much is that a problem?
So I think in general, the big oil and gas companies know they've got to reduce their emissions at source. And just techno-economically, it makes sense. You get far more emissions reduction or CO2 removal for your pound, dollar, or euro if you go to the CO2 sources and capture the CO2 there. So you reduce the emissions in the first place. So if you've got a coal power station or cement, about that flue gas, about 10 to 12% is CO2. With natural gas, it's about 6%. If you're trying to capture it from the air, it's 0.04%. So it's a lot more costly to do it, capturing it from the air in any case. What you need to do, why you need to look at capturing from the air is because you won't be able to reduce all the emissions from all those clouds that I showed you, in particular the agriculture and land use change, and potentially some of the buildings emissions as well. So you're always going to have some emissions still, and from the processes that produce carbon dioxide as part of the process, irrespective of the fuel that goes in. So you're going to need something that takes CO2 from the atmosphere as well. But they're right and you're right. It shouldn't be used as an excuse to continue emitting as normal. And I don't actually know anybody who's actually thinking that way either.
So you agree?
It's a fair charge to put out there, but I don't think anyone is.
Yeah, so
if you look at all the corporate strategies, if you look at the discussions that goes on in shareholders' meetings of the big companies with carbon disclosure and the risks to climate change and what action they're taking, You know, there's very interesting shareholder pressure being put on the likes of these big multinationals, and they take it seriously.
Well, we've seen that in Exxon as well recently, and a number of other industries, haven't we? But so you agree with James Hansen, who's probably the most famous climatologist in the world, who argues that offsetting can be monkey business if it stops people, stopping their emissions. And he argues that carbon capture should never be an alternative to stopping emissions. It should be an addition to it. And is that your view?
Yeah, so that, when he says carbon capture, I think he means the direct air capture, carbon capture. That's right. It's got to be in addition to reducing emissions. That's absolutely correct.
So, I mean, the other concern that some people have is that it's been argued that high fossil fuel emissions places a burden on young people, particularly, to undertake massive technological CO2 extraction if they're to limit climate change and its consequences. In other words, we've placed a burden on the next generation to do all of this. And do you understand their concern about that?
I think that's absolutely right, and it goes across the board of all the low carbon technologies and climate change in general. We're pushing the burden onto the future generations, and that's wrong. You know, we've got the ability to deal with it now. We should have been dealing with it 10, 20 years ago, actually. We've got the ability, we can't go back in time, but we can certainly start dealing with it quicker and faster now for that very reason. Yeah.
Okay, and the other thing that has been said is that with offsets, the lifespan needs to be considered as the same as that of carbon dioxide, and carbon dioxide can last for hundreds of years. So can your technology cope with that? I mean, the lifespan of carbon dioxide goes past corporate lifespans, human lifespans. It goes into a period that we cannot foresee. And there's always a chance that something will happen and it will come out and we will have feedback loops which are incredibly explosive. It's a sort of apocalyptic, future when you look at it that way. So, I mean, do you feel that technology that you're developing can withstand those hundreds of years?
Yes. Easily for thousands and millions of years, for geological timescales. And we know because the geology, the nature, the Earth's already shown us how to do it with the CO2 that's down there already. So we know we can do it. But what's important is proving that it's going to stay down there. And that's where the regulations come in, and they have this requirement to show for CO2 geological storage in the EU. It's, if you look at the role of the operator and the regulator, it's about 50 years worth of monitoring after the project's finished. In California, it's 100 years worth of monitoring after the project's finished. This is an obligation on companies and regulators to do this. The more interesting challenge is not CO2 geological storage, but nature-based solutions, which generate offsets, which are used for offset projects as well, forests, afforestation, reforestation. So under the Kyoto Protocol, because of the risks that your forest may burn down after the end of the crediting period and release the carbon dioxide again, or be chopped down and turned into grazing for beef or something, they only issue temporary credits under the Kyoto Protocol for such projects. Now that Kyoto Protocol's finished, and we're now under the Paris Agreement. There's still the climate politicians are still working out the rules for such things under its Article 6. But nature-based solutions, yes, they're very good, and there's lots of side benefits as well in terms of biodiversity. But the permanence of the CO2 removal has got to be looked at carefully because it's not necessarily long-term. With your soil carbon, the farmer could 5 years down the line sell his farm to somebody else, they change the practice and the CO2 is released again. So there's an immediate benefit from doing it. While your forests grow, there's an immediate benefit from doing it. But once they mature, they're stable stocks, they breathe in and out, CO2 comes in and out, fine. But you've then got to plant more forest to get more CO2 capture really at scale going forwards. Lots of side benefits as well, but the carbon accounting side becomes quite complex because of that very permanence issue that you just asked about. The CO2 geological storage is the easy one because everyone looks at that and goes, oh yeah, you can do that and it's permanent.
And trees are a real problem, as you said, because of their lifespan isn't that long. I mean, we're in such an emergency, really, that, you know, we can't take one solution. We've got to look at several solutions, haven't we? We've got to look at technology. We've got to look at sort of human solutions. We've got to look at stopping emissions, which means government action and international global action. We really have to address this in a multidimensional way, don't we?
We do, and across all sectors of society. We need all the low carbon technologies in the energy sector, but there's the emissions from other sectors as well. So we need all the work on reducing emissions from agriculture. And we need the behavior change as well. But that's not, so what that's good, it contributes. It's not an answer on its own. And I know some people argue that it could be, but we've just had a great example with COVID. Has caused a massive behavior change in the world. Everyone stopped traveling, but it only reduced emissions, CO2 emissions by 7%. That's all. So we still need to look after the other 93% to get down to net zero. Your electricity side produces about a third of those. So you'll have renewable electricity, great. Then you've still got the industrial emissions and the agriculture and land use change side as well. So we need to be doing things across the board.
Okay.
And everything's worth doing because it is the biggest challenge that we're ever going to face. So it must be taken seriously and move quicker. Okay, and that's why I'm very happy to talk to groups such as yours.
Yeah.
Okay. Technology, CCS, it's only one piece of the picture, but I'm very happy to talk about it.
Okay, well, we sort of come to the end of the 30 minutes now, and I guess we could go on for a long time. If anybody wanted to find out more about what you do, get in contact with you, find out more about carbon capture, what would they do? Where would they go?
Best Google our website, IEAGHG. It's probably the easiest way. It's on the back of my slides as well, but if you just Google IEAGHG, and then you can see what we do, and you can contact us through that as well.
Okay, well, thank you for doing this, and thank you for the Over 50s Forum suggesting to us that you do it, because we are in a real emergency, much more I think than people realize or understand deep down. I'm looking at all sorts of approaches to addressing climate change, to the mitigation factor is absolutely essential. So I think listening to what you've had to say, I think will be helpful for a lot of people and will give a lot of people food for thought as well. So thank you very much for doing this, and it's been great to interview you. So we'll end this part of the interview now.
Okay, thank you very much, Francis.